Okay, a moment ago I just showed you how to break numbers into prime factors. Here's where that's going to get a little bit spicier. Let's say you want to factor not just a number, but an equation or an expression. Let's say you have x squared plus 4x plus 4. And you think, by the distributive property that we learned a little while ago, or at least reviewed a while ago, what is the prime, well, not prime, but what are these simple expressions we can factor that into? So since it's an x squared term, we're going to have an x plus something times x plus something, even if one or both of those somethings is negative. So because we have a 4x, let's say we've got x plus a and x plus b. If we distribute that out, then we get x squared plus ax plus bx plus ab. Because we get that from here, we get this from here, we get this from here, and that from there, whenever we multiply that out with the distributive property. So upon seeing that, you're like, oh no, what am I going to do? Well, here's the kicker. Since a and b are the numbers that you're doing, you can actually combine like terms, meaning you can add the ax to the bx to get something called x squared plus a plus b x plus ab. You might already see where I'm going with this, but if you don't, here's what we're going to do now. So this a plus b is the term that's replacing the 4 right here, because it's the coefficient of x. And the ab is the term replacing the 4 here, because that's the constant term. Now what we can do is we want to find two numbers that add together to 4 and that also multiply together to 4. Now, if we want to do that, here's where the factorization of the numbers comes in from earlier, the prime factors. What numbers are the factors of 4? The only two numbers, whole numbers that is, that can multiply together to get 4 have to be from its list of factors. Not just its prime factors, but the numbers that divide it evenly. So I'm going to use a blue marker for a moment here and say the only numbers that divide 4, factors of 4, are 1, because 4 divided by 1 is 4, 2, because 4 divided by 2 is 2, and 4, because 4 divided by 4 is 1, and nothing else is going to divide it evenly. So the only things that we even can choose from, we need two of these that multiply together to get 4. So either 1 and 4 or 2 and 2. I'm going to go ahead and put that closer on the screen. And now, one of these pairs needs to add together to get 4. So if we take 1 plus 4 and we add them, then we're going to get 5, so that doesn't work. Meaning the only choice we have left is 2 plus 2. And it might sound super basic or it might sound super complicated, but that allows us to say that A and B are both equal, are both equal to 2. Showing us that x squared plus 4x plus 4 equals x plus 2 times x plus 2. I'll do one more example and go through it a little bit more quickly, just so that you have the opportunity to see it in action with something that doesn't have equivalent terms that multiply together. So again, we're going to remember, actually let's just start with the x squared plus 5x plus 6. So we're going to, again, need this in the form of x plus a and x plus b. So now, we're going to need to find numbers that multiply together to get 6 and add together to get 5. So right here, this is going to give us x squared plus a plus b times x plus ab. So we need, of the factors of 6, we've got 1, 2, 3, and 6. This pair multiplies to 6, and this pair multiplies to 6. And no other pair can do that. So we either have x plus 2 times x plus 3, or x plus 1 times x plus 6. In this case, 1 plus 6 in this term here gives us 7, so we can't do that. But if we do a 2 and a 3, they add up to 5, which shows us that x plus 2 times x plus 3 equals x squared plus 5x plus 6. Feel free to message me directly or to ask a question in class if any of this seems unclear to you. But until then, have a good day.